Hey everybody, Mr. Welch here. Today's lesson is special right triangles, and they're very special. Okay, so we know some things about right triangles. We use the Pythagorean theorem on them. They have two legs and a hypotenuse. Okay, and special right triangles is really a shortcut, okay, to some of that, to doing the Pythagorean theorem. And you see these a lot. They like to put these on the SAT and ACT tests and those type of things. Okay, and let's get right into it. It looks harder than it is, and this, you're going to have to take notes on a regular notebook piece of paper. Okay, so you might be having to pause me if I happen to go too fast. Okay, the sides of a 30, 60, 90, and 45, 45, 90 triangles have these relationships. Okay, they always have these relationships. Okay, so I have a 30, 60, 90 right triangle. And of course, these add up to 180. The sides are always proportional. Okay, and that means they always have the same ratio. And I like to call this, in this triangle, this is the short side, the medium side, and the hypotenuse is the long side. But the short side is always x. This side is always x times square root of 3. And the hypotenuse is always double the short side, or 2x. Okay, so draw that picture and write that down. Then I've got a 45, 45, 90 triangle. Well, these two sides are the same. Okay, if that's x, that is also x. Okay, they have equal angles, and we'll learn this in a later lesson, that this is an isosceles triangle. The hypotenuse is always x times square root of 2. Okay, so if you were in class, I like to spend a little time doing this, that it looks hard because I got the square root of 2, I got x in there, it looks really mathy. But if this side is 10, well, this side would be 20, and this side would be 10 times square root of 3. Okay, if this side was a million, if x was a million, this side would be a million square root of 3, and this would be 2 million. Okay, so they're always in that ratio with any number, and I usually start with the short side. If this is say 3, well, this would be 3 square root of 3, and this side would be 6. Okay, same thing for here. If this is 10, well, this side would be 10, and this side would just be 10 square root of 2. Okay, if this was a million, this would be a million, and this would be a million times square root of 2. All right, so up here in the corner, I have our formulas, or our equations that we'll use for all of these, and you can write this one down. Some of these you might not need to write down if you get the idea. If this is 10, well, what's this side? This is a 45, 45, so I know this is isosceles. So x is 10, and y is what, people? 10 square root of 2. Okay. And I kind of got confused. Is it the one where I use the square root of 2 or square root of 3? Well, I remembered it like square root of 2 goes with the 45, 45. Okay, and square root of 3 goes with the 30, 60. Okay, and again, don't write this one down. We kind of did this one. If this is 100, this is 100. This is 100 square root of 2. Okay, this time You might write this one down if you need to. This time they give us the hypotenuse is 8 square root of 2. Well, that just means these are both 8 and 8. Okay, so pretty easy so far. There are some harder ones. We'll get to those. But if they give you either of these sides with the square root of 2, it's just use the formula or use our model. Okay, here's a 30, 60, 90. So you might write this one down. They give me the short side. So it's find x and y again. Well, this is the short side. This is the medium side. This is the hypotenuse. So x is 10 square root of 3. Okay, the medium side's always whatever the short side is times square root of 3. And what is y? 20. Okay, it's just double the short side. Okay, probably don't write this one down. This is the same as the other one. If they give me the short side, we got this. Okay, if this is 5, x is 5 square root of 3, and y is double the short side, so it's 10. Okay, this one, go ahead and write this one down, I suppose. This time they give me the long side, or the hypotenuse. So, and we're on the 30, 60, 90, so that's 2x. Okay, well, that's double the short side. So what is the short side? So now I call this working backwards, but we've been used to getting the short side, but now they give me this. Well, it's half of that, or 25. And then I know this y, the medium side, is always what the short side is times square root of 3. So it's 25 square root of 3. Okay, don't write this one down because we don't need to. If that's 4, I know that short side down there is 2. And I know y is just 2 square root of 3. Okay, again, maybe write this one down. It's still not too hard, I don't think. Some of you might get it like that, but they give me the short side. They were nice, and they gave me a square root of 3. So I know that x, the short side, is just 6. And then what would y be? Double the short side, so 12. Okay, here's you if you were in class. Ready? What is y? 1, 2, 3, b, because it's 4, half of the hypotenuse. What is x? 1, 2, 3, b again, because it's 4 square root of 3. Okay, here's another one. 1, 2, 3, what is x? D, delta, 35. And what is y? 1, 2, 3, delta. There's the camera, delta. Okay, again, hopefully we're getting it. If this is 3, what is x? 1, 2, 3, d. What is y? Well, 1, 2, 3. Whoops, it was 3 square root of 2, whichever answer that was. All right, now this is the hard ones. So we're getting into a couple of hard ones here. So write this one down. Okay, they weren't nice this time. They didn't give me a square root of 2. So if they gave me a square root of 2 here, well, then this would just be 10 and 10, but now they're trying to trick me. Okay, and you can also do this using the Pythagorean theorem, and I'm going to show you that. here in a minute. But let's do special right triangles. Okay, they give me that one is 10. So I know this is x times an x, and this is x square root of 2. So 10 equals whatever x is times square root of 2. So in this one, I just have to do some algebra skills and use my knowledge of radicals that we did. I divide by square root of 2. Okay. And then I don't want a radical in the denominator, so I times both top and bottom by square root of 2 over square root of 2. And you might pause me here if you need time to write it down. But square root of 2 times square root of 2 is just square root of 4. And I know square root of 4 is just 2. And then 10 divided by 2 is 5. So this is 5 square root of 2. Okay, so this side's 5 square root of 2, and this side's 5 square root of 2. All right. And that pattern works too. It's just half of this times the square root of 2. But we need to be able to figure it out. Okay, here's another way to do that. I can do x square root of 2 equals 10, and then I can square both sides. Well, the squared and square root cancel each other out. X squared is just x squared. So this is 2x squared equals 100. And then I divide by 2, and then I square root both sides. And square root of 50. The squared and square root cancel each other out like in our Pythagorean theorem. And 50, if you remember how to simplify your radicals, that's square root of 25 times square root of 2. And the square root of 25 is just 5. Okay, and you don't have to write that one down. It's just maybe it helps you to see another way to do it. Okay, and here's still another way, and I'm going to go through this quickly. This is using the Pythagorean theorem. X squared plus x squared equals 10 squared. Well, that gives us our 2x squared again, and we go through the same steps. Square root, simplify our radical, 5 square root of 2. Okay, I'm going to stop this video here because I think I'm short on time, and we'll come back and do just a couple more examples, so stay with me just for a couple more.